So consider this. An experiment consists of two trials. In trial one, you could get two different circumstances. You can get A or B. That's it. And they tell you what the probabilities of each one of those occurring are. And there's two outcomes in the second trial. You can either get C or D. Now, I'm not saying what these things are. They want you to draw a tree diagram representing this experiment and use this diagram to find these. Tell you though, honestly, you don't really need the tree diagram to answer these questions to a certain degree. But, because a lot of these are easily handled by the formulas that we have and that we've mentioned already. So, because a lot of these have been given outright. So, but the tree diagram should definitely agree with it. So, you are asked to draw a tree diagram. We'll look and see about that in a moment. But find these probabilities. From the information that we're given in this problem, we're told that the probability of A is 0.4, the probability of B is 0.6, the probability of C is 0.3, and the probability of D is 0.7. So when I look at this, to ask the question, what's the probability of A? Well, that just came right out, and that's 0.4. That's all it is. I'm going to look at B and D at the same time because we are dealing with independent trials. Now within the trial, the events might be. I would say A and B are probably not independent because it's only one can occur, or those are the two possible outcomes. If A occurs, then B is probably not going to occur. That's dependence. But whatever the two trials are independent. So if I say, okay, the probability of C occurring given that A occurred. Those are two different trials that are independent of each other. And since those are two different trials that are independent of each other, then the probability of C given A and the probability of C are going to be the exact same thing. They're both going to be 0.3. So it doesn't matter if A occurred or not. The probability of C occurring is going to be 0.3. And therefore, the probability of A and C is just going to be me multiplying the probability of A times the probability of C together. Although I could say the probability of C given A still. That's still what the formula that they have us use. But remember, the probability of C given A is the probability of C. So in any case, I get 0.12 for the probability. So pretty easy question that a lot of students overlook. So be careful with things like this, that you don't overlook clear definitions and things along those lines, because that can certainly cause problems down the line.